So what we're going to do is we're going to start with a quick skill. Okay. So let's say that we have the following. We have 2x squared plus 4x minus 30. The key here is we're going to combine our common factoring followed by 2 factoring. Okay, if you get to the end of today's lesson, question number 7, then yeah, you might have to do this. Okay, if you don't, that's fine. That's okay, don't worry about it. So the key idea, so the first thing that we got to recognize, we can factor out 2. i.e. the GCF is equal to 2. And that will always be for the number that sits in front. So just remember, if you see a number sitting on the x squared term, we can always pull that out. So in this case, we're going to get y is equal to 2 bracketed with, well, we write our x squared plus 4x and then minus 30. And then we divide everything by 2. This is why we were practicing this stuff, so we could combine all the math that we had learned. So we end up with y is equal to, well, we got x squared. Oh, sorry, this should be a 2x squared. Now, that 2 and that 2 cancel, so you're left with 1x squared, which is just x squared. And then we have 4x divided by 2. So the 4 and the 2 cancel out, and you're left with positive 2 and then x. And then negative 30 divided by 2 gives us negative 15. So this part here, we've applied the common factor, right? So that was step 1. Step 2 is to literally factor this part. So in order to solve this problem, mathematically speaking, what we do is we take a moment and we literally just write y is equal to 2 with 2 separate brackets here. And then we write an aside here. And our aside is going to go and take a look at x squared plus 2x minus 15. And we're looking for 2 numbers that multiply to something, but then add 2, multiply to negative 15, but then add to 2. Those 2 numbers are negative 3 times 5, which gives us negative 15, and negative 3 plus 5, which gives us 2, which is what we want. So the numbers are negative 3 and 5. So this green part here literally factors into these 2 things, and we end up with x and x, and then we have our minus 3 and our plus 5. So this is how you go and factor questions number 7 in our lesson. Okay, good to go. And so now let's move on to the overall lesson of the day. So today's lesson is called Representing Quadratic Relations, and what we're literally trying to do today is to maximize our knowledge and understand the math behind the geometry. Let's call it the shape. All right, so pause the video, make sure you have this written down as your title, and then go and do the enriched lesson that I've provided for you. This lesson should take about 25 minutes. So imagine we have the quadratic relation y is equal to x squared plus 2x minus 15. We need to figure out whether this equation has a maximum or a minimum, okay? We also need to find out what is the y-intercept, right? And what are the zeros of the solution. Now, today's lesson is all about explaining how all of this stuff comes together, okay? Now, the first thing that we're going to do is we're going to identify if our equation has a maximum or a minimum. Now, let's go and take a look at the basic equation for our parabolas. Now, as an aside, you're going to have your note, and then there'll be a calculation beside it. That's what we'll do for this lesson. And then we'll summarize it at the end. So the basic equation for a parabola, also known as a quadratic, is given by this standard basic equation. Y is equal to ax squared plus bx plus c. The type of calculations that we have allow us to look at these equations and say whether our equations are opening up or down without having to graph them. So for example, if I have the following for my equation, for my parabola or quadratic, you'll write y is equal to, let's say I have y is equal to x squared plus 2x minus 15. I can tell you that based on this original equation that I have above here, the a value doesn't have anything there, but really it's a 1 that's sitting in front of the x squared term. Now, this a value that we're looking at is greater than 0. So this means our graph opens up. So our graph looks like this. Okay? Or it looks like this. Or it looks like this, just touching the x-axis. But I'm going to tell you right now, it actually looks like this when we graph it. Now, based on all this information, we can determine that this is a minimum. So now let's go and answer that first question. So you go A, since the A value is bigger than 0, that means that that the graph opens up which means it is a minimum. Now, let's go back to our quick note here, right? So now imagine if I had another equation like this. Y is equal to negative x squared minus 2x plus 15. So all we've done is taken the negative of all this, right? The key concept is if a is less than 0, this thing opens, well, this one opens down. So instead of opening up, it opens down. And in this case, our a value is instead of 1, it's -1. Okay? So it opens down. So our graph would look like this, either underneath the graph, or looks like this, crossing the graph, crossing the x-axis, or looking like this, just touching the x-axis at the vertex, right? And because this is the case, we can kind of give an idea of what actually is happening. So when it opens down, this is a max. When it opens up, it is a minimum. So let's put this in blue here. So we have a max here. No, a minimum there. Because it's opening up. And it is a max if this thing opens down. All right. So now we have part A answered. So now let's move on to part B. What are the zeros of our solution? Okay. Now, the zeros of our solution come about by actually tying into what we studied before. So when we're looking for the y-intercepts, we have to think about what we used to do before. So when we had a line and we wanted the y-intercept, we would let x equals 0, and then we'd find our number, and it would give us this value that was on that line there, right? So guess what we have to do for our parabolas? So anytime we have a parabola or a quadratic form or something that we want to use, here's what we do. For the y-intercept, here's what we do. We let x equals 0 in our standard equation. Y is equal to ax squared plus bx plus c. So that means we got y is equal to a times 0 squared plus b times 0 plus c. What the heck? So in this case, 0 times anything gives 0, so that's gone. And this goes away as well. So in the end, we always have the c value. So this means the y-intercept is the constant term. So otherwise, we always just have to let equals 0 and find our answer. Okay? Now, for this basic form, here's what we do. For part B, it says, what's the y-intercept? Let's write that out. B, what is the y-intercept? Now, you can do what we did over here by letting x equal 0 and finding the c value, right? And it will work all the time. Now, if you don't want to do that, you just look at our basic equation. So here's what we'll do. So there's two ways to find it. Two ways. One, you let, so for y is equal to x squared plus 2x minus 15, we let x equals 0. So now you've got y is equal to 0 squared plus 2 times 0 minus 15, right? And then you end up with 0 going away, and 2 times 0 goes away. So you're left with y is equal to 15. Sorry, negative 15. Right? So you would say your y-intercept is negative 15. Okay, now if you wanted to, you could say, you could say this, or you could give the point. 0, negative 15. And there we have it. That's one way to do it. Okay? Now, the other way would have been to just say, hey, recognize that your equation is in this form right here. And then say, you know what? Forget it. We know that our y-intercept is negative 15. Boom, we're done. All right. So now what we have to do is we're going to have to go and take a look at this next thing here. All right. Part C, what are the zeros of my solution, right? So let's go and take a look at what that means. The zeros. Zeros refer to the factored form representation of y is equal to a x squared plus bx plus c. Hey! So here's what it means. Your basic equation looks like this. Y is equal to a times x minus r, x minus s, where x minus r, x is equal to r and x is equal to s are roots, otherwise known as zeros. Okay, so this is how we do this kind of problem. Okay, so the reason why we factored a while ago was because we always wanted to find the solution to a problem, i.e. factoring it, right? We used factoring to help us find the two linear calculations of the two linear stuff that built up the expansion, right? Now, in mathematics, essentially what we're doing is finding zeros, okay? So the key idea here is you're going to let y equals 0, and I will show you what happens in order to find our roots. So here's our basic equation. So we have this equation. Y is equal to x squared plus 2x minus 15, right? The first thing that you have to do is you have to let, you're letting y is equal to 0, because essentially what we're looking for are those 2 points on our graph here where the y value is 0 and it crosses the x-axis. So when you do that, your equation becomes this. Now, let's see if we can move this up. So now we have this going on. So we let y equal 0, and remember what I told you. We're letting y equal 0 so we can find the x values that give us what we're looking for, okay? So this is why we did factoring before. So you start with this. 0 is equal to, now you've got your x squared plus 2x minus 15. The key here is to factor the right side. So now, when you factor the right side, we're looking for two numbers that, well, multiply and add to something. So we're looking for some things that multiply to negative 15, but then add to 2. So those two numbers, when you go through all the possible combinations, are this: positive 5 and negative 3. So let's try that. 5 times negative 3 gives us negative 15, and 5 plus negative 3 gives 2. Oh, yes, that works. So here's what we write for our factorization. So you're going to say 0 is equal to this. X minus 5, no, x plus 5, and x minus 3. Now, in order to find the answers here, you got to understand, you're saying 0 is equal to either this thing or this thing. So this whole thing will have to be equal to 0. So either this part's equal to 0 or this part's equal to 0. So here's what I do. I tend to split these off and say, well, x plus 5 equals 0, or x minus 3 equals 0. And then I just solve, well, x is equal to 3, or x is equal to negative 5. Well, look at that. So now you can say, so our zeros are the following. X is equal to -5, or X is equal to 3, which means we have points of -5, 0, or 3, 0. And that's it. That's literally it. The key to solving all of our woes was all that stuff that we were practicing before. So before, when you were finding your lines, you could always find your x-intercepts and y-intercepts. Now, this is this. In order to get this, we have to factor, don't we? And we call this the factored form. So I could also say here, as a note, let's put a big side here. So basically, y is equal to x squared plus 2x minus 15 can be represented by this equation. Y is equal to x plus 5, x minus 15. And remember, we also call this the factored form. And the factored form is useful in the sense that we can find the zeros easily. Okay? This allows us to find the zeros, but you understand what we had to do. So in order to do this, we had to factor. Okay? So remember, we had to start by 1, letting y equal 0. And then 2, we had to factor the right side. And then 3, get our numbers. And then 3, you're going to let each of those brackets equal 0. Okay? So there are 3 steps to that. I'm not going to show you how to do this. I just want you to use this problem to find solutions. Now, the last part of our problem asked us to find something. At the very end, they said, what is the maximum or the minimum? Okay, so let me show you how to actually calculate the maximum or minimum. So this is the note that I want you to kind of put beside your math. So here's your note. To find max or min. Here's what you do. To find the maximum or minimum in an equation that looks like this, y is equal to x, let's go, ax squared plus bx plus c. The x value for the max is given by this. You got to do this first. 1. Find the x value for the max. Are you ready? You go x is equal to negative b divided by bracket 2a. That's it. And then 2, we sub this. Notice I'm putting this in black. Sub our x to find the y. So basically, when we're looking for the max, that's what we do. And guess what? Because this works for all, this solution will always be used to find either our maximum or our minimum for our parabola. And we remember that at the beginning of our problems, we decided that our parabola was a minimum, right? We said that our parabola was a minimum because of our x value being our a value on our x term being greater than 1. Okay, now, so it's always you look on the x squared term and you see if there's a number in front of it and it's greater than 0, then you know it's opening up, so you have a minimum. So now let's go back down to our problem, and we'll take a bit of a little breather, and we'll go over this again. So in order to find the maximum or minimum, right, here's what we do. We have to take a moment and we have to sub our x, we sub the x that we get from this calculation here. Okay, so let's go and do that right now. So let's say that I have the following. So we're going to go and find the max. So this is part C. We're finding the max, no, the minimum for y is equal to x squared plus 2x minus 15. So here's what we do. Plug that in, get your answer. So let's go for it, shall we? So when you do that, you're ending up with y is equal to, oh, not y. The first thing that we said we had to do was find our x for the max or min. So let's go and actually write that out. The x for the min is going to equal this. So we start by writing our equation. X is equal to negative b divided by 2a. So in our original equation, there was a 1 in front of our x value because there's nothing there. So our a value is equal to 1, our b value is equal to 2, and our c value is equal to negative 15. So all we care about is plugging that into our equation. So we end up with x is equal to negative of, well, b is 2 divided by 2 times 1. Now, if you're doing this by hand, don't punch it in the calculator right away. Just put negative bracket 2, and we're going to simplify this part here. So 2 times 1 is 2, and then 2 in brackets is just 2, so we get negative 2 divided by 2. And then we simplify the top, so we get negative 2 divided by 2, which is negative 1. So the first thing is done. So the x value for our minimum is negative 1. So that's what we did for step 1. Step 2 is given by doing this. Not that, but doing this. What we're going to do is step 2. So now let's we're going to sub our x into the y, the basic equation. So let's start. We're going to go y is equal to bracket squared plus 2 bracket minus 15. Now that negative 1 needs to go here, and it also needs to go right here. So we end up with negative 1 squared minus 2 times negative 1. Punch negative 1 squared in your calculator to get 1. And then 2 times negative 1 gives us negative 2. And then minus 15. And you end up with y is equal to negative 16. So look at that. We didn't have to use Desmos or any graphing or anything like that. So you now can say the following. So the minimum is y is equal to -16. So instead of graphing, if you don't have the ability to graph, this is what you can do to find your max, your mins, your roots, and your overall stuff. So as we did this, you know that we took our time and we used all this information to help us pull all our details together, right? So when you do a problem like this, I'm going to give you 2 or 3 problems today. You're going to use this to do your problems. Now, I'm actually going to take a minute. I'm going to make sure that I have all of this stuff set up for you so that you can do these questions. All right? Okay. I'll also make sure that you have pictures for each one of these. All right? And let's go for a quick summary. Our basic equation for a parabola is given by, a parabola or quadratic is given by y is equal to ax squared plus bx plus c. Now, this is a quadratic relation, right? Now, one of the things that it gives us is this thing called the standard form. So the standard form is just the expansion of this form. Y is equal to a times x minus r, x minus s, where x equals r and s are roots. And in order to find that, what we did was we let y equal 0 and factored. Now, please make sure that you call this the standard form, not the standard form, the factored form. We also know from this basic equation here that to find the minimum or max, we have to find x is equal to -b over 2a, also written as -b divided by 2a. Now, this actual thing here, I didn't mention it, is called the axis of symmetry, right? And we use the axis of symmetry when we're calculating to find our y value. So, and then you sub into, let's call that the big star, to find the minimum. Now, graphs open up. So if a is bigger than 0 or a is less than 0, here's what you do. If our if our a is greater than 0, it's a smiley face, it's opening up. If our graph is less than 0, it's opening down. And both of the a values that we have here and here tell us whether our graphs open up or down. And you can use that to help you figure out how to find these things. So that's it. That's all we studied. Now, keep that note that I gave you. I'll also put a copy of it online for you so you can automatically find what we're looking for when we're doing our calculation. So for question 1 on page 333, I want you to find the maximum and minimum and the zeros for our question. The next one is I'd like you to take a look at number 2, and I want you to answer the following. Just answer the questions on there. You need to find the max. Tell me if it's a max or a min. You also need to tell me the y-intercept. You also need to tell me the y value for the max or min. Okay. And then to challenge you, extra challenge, we'll call this 3 and number 4. So do the work for 3 and 4. And then you're going to work on number 7. The equation is y is equal to 6x squared minus 36x plus 154. That problem is exceptionally hard. Okay, the first thing that you have to do is, 1, you need to common factor first, i.e., pull out a 6 to start, and then do the rest of the problem.